Welcome everybody for today's Sustaining the Warfighter panel. I'm Lieutenant Colonel Rob Fekete, the commander of the mighty 4th Logistics Readiness Squadron at Seymour Johnson Air Force Base, North Carolina. And we have an incredible panel today of logisticians and professionals for Sustaining the Warfighter discussion. We're fortunate to have join us this evening Major General McCauley von Hoffman, the Director of Logistics, Civil Engineering, Force Protection, and Nuclear Integration Headquarters Air Force Materiel Command at Wright-Patterson Air Force Base, Ohio. Brigadier General Jennifer Hammerstedt, the Commander, Warner Robins Air Logistics Complex, Robins Air Force Base, Georgia. Brigadier General Dave Sanford, Commander of the Defense Logistics Agency Aviation at Richmond, Virginia, and Dr. Glenn Daehn, Mars G. Fontana, Professor of Metallurgy Engineering at The Ohio State University, Columbus, Ohio. Thank you for joining us today. Before we get started, this panel is designed to be interactive. If an audience member has a specific question, please use the app, and then the staff will pose the question to the panel members. Finally, this panel will focus on the traditional challenges in the sustainment enterprise, and keeping with the Chief of Staff of the Air Force's maxim to accelerate, change, or lose, we'll discuss some of the more innovative efforts in each of the panel members' organization. To break the ice and get the conversation going, I have a couple of questions for each of the panel members, and to start us off in no particular order, I'll start with Dr. Daehn. Dr. Daehn, you are part of a team that is pioneering an advanced manufacturing technique known as robotic blacksmithing. Can you please describe your efforts and talk about how it's different from additive manufacturing? Could you also touch on some of the difficulties associated with additive manufacturing and how the sustainment enterprise can overcome some of these challenges? And finally, what do you see as the future state of producing customizable items in small batch quantities or single issue units, and the challenges to get to that state?
Okay, a lot of questions buried in that. So first, thanks for having me here. It's really a pleasure to be part of this community. Welcome to this community. It's been awesome. To get to your questions, and again, make sure I hit them all if I don't. But robotic blacksmithing, the key idea is we've gone through this, first of all, the revolution of machining. CNC machining started with MIT back in the 1940s and has been growing in how we use it ever since. It's based on this G-code path where you bring a cutter through a piece of material to reveal this part that you want. So then we got into this thing of additive manufacturing. It's basically the same G-code path. In order to, instead of removing material, we add material. And it's really a challenge to get good material by addition. We're getting better and better at it, but we've never really designed materials to make them from powders into real components. It's a challenge, and we're pretty good at it. And you typically don't get the same kind of properties and reproducibility with an additively manufactured component as you might with a wrought component. And wrought is a word, it's the past tense of work, which means you've deformed the material. You've taken it like bread dough and somehow extruded it, worked it. That's how you get your best material. So forged materials are examples of some of your very best materials. So we've been inspired by the artisans, by the blacksmiths. Blacksmiths for a long time have deformed things into very useful shapes. Suits of armor, swords, maces, tools, horseshoes, all of this stuff. So we can make very complicated shapes that way, and we can also maintain that wrought structure, the very good structure that we get the very best properties with. So we're working with a team, people at Ohio State, where we have colleagues at other universities we're working with, and we have a program with Warner Robins Air Force Base. We're starting to get some of these things going. It's the early stages, but it's to do numerical deformation. Can we figure out tool paths to use deformation processing to make interesting shapes, meanwhile, or useful shapes, the same shapes you have on aircraft, and really maintain the materials properties. So this can be something that works in tandem with additive manufacturing. For example, take an additively manufactured part and then do numerical deformation to it in high stress spots. And with that, we can make things that are actually better than the parts that they might be replacing. Whereas additive often, wrought is kind of the gold standard you're trying to get to. If we do this right, we can probably go beyond that. So that's the big idea that we're working for. Is, and, we've got brought in just a little tiny demo piece, but this is just a rectangular piece that was done basically just taken and We just use a robotic arm to move it, and then have a press that moves up and down. We can do this hot, we can do this cold, and we're just really getting this going. And we're hoping that in a small number of years, this can be a mainstream technique that serves warfighter needs. And commercial needs as well. So,
all right. Thank you, Dr. Daehn. Next question is for General von Hoffman. AFMC has a large civil service population, many of whom are one deep, highly marketable to the private sector, or rapidly becoming retirement eligible. Can you please speak to some of the challenges of hiring, training, and retaining our civilian airmen, and talk about how AFMC is addressing talent management throughout the sustainment and product support enterprises?
Yeah, thank you. So I'll just address that civilian population real quick to level set everybody. So in Air Force Materiel Command, there are about 70,000 Air Force civilians that are serving in various capacities. That's 40% of all the civilians that serve in the Air Force. So obviously a large population. From the sustainment and the product support standpoint, many of those are in the Air Force Sustainment Center, but also we have maintainers in the test center and in IMSC. We have log plans folks there, and then of course we have folks in the Lifecycle Management Center. So a broad spectrum across AFMC. There are hiring challenges, there are training challenges, and retention challenges, as you mentioned. And I'll just kind of start with hiring challenges. Some of them, we're looking for particular technical expertise, and there is a huge demand, no surprise to anybody in this room, both for folks with technical skills and just a demand to get people in the door. So just a demand for high school graduates, not only people with experience. And in a lot of the places where we have AFMC bases, there's a huge aviation industry. It makes sense that they are, and so there's a big demand for that talent and a lot of competition. One of the things that we're doing to get after that as we're competing and trying to hire those folks is definitely working with the technical schools and the universities. So the Davis Technical College that's just north of here, we work with their curriculum so that people that enter that tech school know that there is placement for them on the way out. So we work with them on their curriculum, and we recruit. We're in their classrooms as soon as they're walking through the door. And then there's Rose State College outside of Oklahoma City, and there's and Mercer College in your area, as well as Weber State, where we work also with them on curriculum that is supportive to the sustainment enterprise. And again, so that people that are, students that are going through those courses, we have a relationship with them while they're going through that school. And so that applies for our software engineers as well. We have internships programs with our software engineering groups with universities where they can come in and test drive us. And it has a great benefit also. A lot of times we have an early start on starting things like their clearances and things like that that are very hard. So lots of ways to get after that hiring challenge. We're using the art of possible theory of constraints in our hiring practices. A lot of times we will actually hand somebody a job offer, and they wait 4 months for us to get through all the mechanics of bringing somebody into civil service. Many of you in this room may have experienced that. So we're using art of the possible theory constraints to compress that time so we don't lose them after we've actually hired them. So a lot of things that we're getting after hiring. Training is very difficult. We have an expectation that our maintenance technicians will have the same skills and the same amount of time as we do of our uniformed airmen, but we don't have tech schools for them. We don't send them to Shepherd Air Force Base to give them those skills. So we do homegrown training things in our maintenance groups, and then go back and assess how well we're doing that. And if it takes us moving individual technicians from one group to another to get them those skills, then we do that as well. Some different training initiatives there. And then retention in civil service is very hard because you can't offer a bonus in the same way with the same ease that you can on the civilian side. But we can't, but there are programs within civil service where we can where possible, we can do some retention, financial incentives. But what we have from a retention standpoint that others don't have is we have a mission. And we've talked about the leadership in this sustainment and the logistics enterprise before, and how important leadership skills are, how important it is to communicate that connection to a mission, because that's one thing that a software engineer, for example, they may be able to go create a user interface that's really cool for an online shopping site. That is not nearly as cool as working on the OFP for an F-16. And they just can't get that. And I have literally heard that comparison listening to some of those interns that have come in that program. So we communicate the importance of our mission and how they're connected to that, everything from the technician, to the software engineer.
Thank you, ma'am. So on the same path, you were talking a little bit more about the technical side of things and working with various colleges and universities to help develop their curriculum. Are you finding you have the same challenges on the blue-collar side as far as hiring folks in the depot and some of the more traditional hands-on things that I don't necessarily believe are as mainstream as they used to be in the younger generations?
There are. So I mentioned Davis Tech is one example. There's examples in all three of the depots and outside of the depots as well. We are having to go into the high school now and work with local high schools and start talking with high school districts about, hey, are you interested not in a metal bending class or a welding class anymore? Although those are relevant for some of our weapon systems, but are you interested in having an introduction to composites in high school, so that we can at least pique that interest to get them into a tech school. But I will tell you, we are also hiring people straight out of high school, no technical schools, and there are paths in civil service to bring them in as a wage grade 3 or a 5, and show them the potential to go up to a 9 or a 10. In that case, where we just bring them in from high school.
Yes, ma'am. Thank you.
Yeah.
General Hammerstedt, recently, Robbins opened Project Synergy, an off-base facility to expand software capability in the 402nd Software Engineering Group. Can you please speak to the necessity of software maintenance and sustaining our weapon systems, and the challenges that the depot is facing regarding software development and maintenance, and some of the depot's innovative efforts to keep pace with the evolution of software?
Okay, thanks. And I'll echo General Barry that the lights up here are really bright, and the only person I can see is my boss, so no pressure. So thanks for the question. If I could, just to piggyback on General von Hoffman on that last question, one thing in terms of the hands-on, the wrench turning, one thing that I would say to this audience, since we have an audience here, is that I think that we can also recruit from our ranks. Now, obviously, we want retention in the Air Force as well, but I think I'm not sure that our airmen are aware of the opportunities at the ALCs to serve if they say that they're, the active duty is not where they want to be. Guard Reserve, certainly, but there's great opportunities at the ALCs as well. So shameless recruiting plug for the ALCs. Okay. So as far as Project Synergy and software, not to repeat what General von Hoffman just said, but so all of you have cell phones on you, Apple Watches. I mean, you can't go anywhere without knowing that everything we do is software dependent, and our weapon systems are no different. So, the talking point you hear a lot is, 8 million lines of code on the F-35 compared to, less than 1 million on the F-15. And now I'm hearing numbers like, actually, if you take the whole F-35 enterprise, it's more like 26 million lines of code. But there's a whole backbone that supports that. And a lot of that is done organically, which a lot of people don't know. Right at our ALCs, we do that software sustainment there. So critically important. And again, not to echo General von Hoffman, but the number one challenge for us are the people that do that work, and recruiting, retaining, and keeping those people proficient. So a lot of the same things General von Hoffman talked about. The cool thing about Project Synergy is that I can't take credit for it. It came before my time at Robbins, but it was a partnership with our local community to refurbish a building that had been vacant for about 10 years. It's state of the art. If anyone ever wants to come look at it, you feel like you're walking into like a Google or a modern day software enterprise. So we have classified work that we do off the installation, and we have a huge footprint there on one side of the building. Right in the middle of Project Synergy, we have a partnership with our local Board of Education where we have high school students who are dual enrolled, so they're getting college credit to come to Project Synergy and do their classwork right there next to our software developers. So they're sharing common space, break rooms, and we have a chance to influence kind of what General von Hoffman was saying, because we realized we have to start way early. So last year was the first year that we started actually a high school graduate intern program. So we took 25 recently graduated high school students who have committed to go off to a university in a sci-tech major, and we brought them on as interns before they even went to their first day in college. So they got security clearance, and then we offered them a job back. We're paying them in the summer, offering them a job back every year. So this year, of the 26, we have 23 of them coming back. So hopefully by the end of the 4 years, maybe we'll harvest 10 future software developers at Robbins Air Force Base. So Synergy has allowed us to do a lot more of that because it's off the installation. So it gives us some flexibility in terms of tapping into that talent. But that really is the greatest challenge we have. I mean, General von Hoffman mentioned it. We used to have at our advantage at Robbins that cost of living was really low, right? And we have great paying jobs. But now with telework and remote telework, people can live in Middle Georgia and work for a company in Seattle, so even that benefit of locality is slipping away. So a huge challenge, and again, we rely heavily on the mission. And I tell you, we have some amazing software engineers, GS9, entry, and I don't know how we keep them, except that they love the mission and they are so good. They're on the cutting edge of everything that we're doing, that we've been talking about this whole week, and we do all that organically. So please come see, if you ever want to come see what we do at the depots in software. It's pretty cool. So thanks for the question.
Yes, ma'am. And I would just like to say that I think there's additional challenges with software in regards to older software. For example, the B2, I think, runs on the equivalent of Pentium 286 processors.
Right. The great thing about that, though, is when we do organic sustainment, we have professionals that stay proficient on all that old software. Just like we have to keep a capability to repair an avionics black box that we may not ever need again anywhere else in the world, same thing with the software. So organically, we keep up on that. So that's one great thing, again, about our ALCs and what they bring to the fight.
Yes, ma'am. Thank you. So far we've touched a little bit on manufacturing, talent management, and software. We'll go a little bit over to the supply chain side in General Sanford. As the primary buyer of consumable piece parts for all military airframes, you, like everybody else, are facing chronic diminishing manufacturing sources and material shortages. From a policy or legal perspective, how can the Department of Defense better incentivize industry to produce the spares we need, and how can we influence that necessary policy change?
So, thanks, Rob.
Yes, sir.
This is a big point of discussion, at least in my organization and really across the agency. And so what I would offer is I don't think there's a legal policy issue. So I'll answer it a little differently. I think it's more of a demand planning discussion. At least that's what we've had with industry. And so I think there's a partnership piece there, because industry they're asking us for the requirement. What do you need? And so I think there's a better discussion that has to be had that's informed with data, both on peacetime flying profile to a wartime flying profile, what is actually needed, and then we understand what the requirement is, and then we can have a better discussion with the industry and have those partnerships and what are the best vehicles to get after that and sustain a long-term demand, which industry wants, versus a sine wave demand supply that we sent now, at least on some parts. There's a lot of vehicles we can get after at that point, but it starts really with the understanding the requirement and where to go. So I haven't felt or been able to identify any legal or policy constraints. I think it's more of just understanding the requirement piece and refocusing what our demand planning is, and then we can get after it from there.
I would definitely agree with you, sir. I think there's a kind of a bad narrative out there that it's a competitive relationship with industry, and I don't find that to be the case at all. Most of the times I've dealt with industry partners, they want to give us the best product, and they want to give it to us at the best price, but sometimes we shoot ourselves in the foot, and whether it's our budget cycle, our acquisition rules, and we don't make it easy. And I think that leads to some of our problems.
I would agree with you, Rob, and I know you and I have talked about it. I wouldn't necessarily say it's competitive. I think there's some friction between industry and the government, more so in some cases than others. But also I think part of that too is that friction is driven by some frustration sometimes on us either providing an outdated requirement or not a fully informed requirement, or not being able to meet a speed requirement that we have when we don't necessarily understand the ALT or the PLT, acquisition lead time or the production lead time to get after the requirement. Now, I think there's with better transparency, there's a pilot program, actually we're expanding it now, but I won't say with what vendor, but it's called supply initiated ordering. And so I'm a big fan of it, and it allows the vendor to really kind of manage the left-hand side of the supply chain. So they get to see the demand data, they get to understand the requirement, and so they use that data and actually manage that on behalf of the Department of Defense. And so we're doing that with engine parts right now, and what we've seen is a reduction in inventory, but more importantly, we've seen an improvement in having the right part when it was needed. So, we like to say material availability, but I like to focus it more on there's an improvement in effectiveness. And so we're going to expand that to some other platforms now, again, focusing on engine parts, but it's that transparency, having access to the data, and then being able to leverage that data. Because what they do is they actually analyze it for us. They tell us when they think we ought to have one in the pipeline, if you will, and then we just pay them. I mean, don't get me wrong, I'm simplifying it. There's oversight and management and so forth, but again, it shows great promise, and so that's why we're going to expand it now. But I think those partnerships are the future.
Yes, sir. I appreciate it. Thank you. So we have about a little over a half hour. I'd like to know if we collected any questions from the audience, and if not, I'll go on to some other questions.
We are collecting questions
All
from
right.
the audience. Good afternoon.
Please.
Excuse me. So I'll direct this question to General Sanford. Sir, what is DLA doing to enable predictive maintenance for the services?
I'm sorry, more predictive maintenance? Or?
What is DLA doing to enable predictive maintenance for the services?
So I would offer that we're not tied in, at least from a supply chain standpoint. So, there's predictive analytics out there that'll tell you, hey, you need to change something, and that's great. So that data is captured when the requirement's sent over to the agency. But there's a piece where that requirement flows through an Air Force system, and then it gets transitioned, if you will, to a DLA system, and then along the way, there's a calculator that says, hey, is this exactly what we want to actually have entered into the system? And then it spits out a requirement. So I don't, me personally, it's Dave Sanford's opinion, I don't think the predictive piece is linked as strong as it needs to with the supply chain to provide more parts on the shelf as it is. I think we'll get there. And don't get me wrong, I'm a fan of the sensors piece and what it'll do. I'm just trying to rationalize, do I have to wait for their history to be built up so that it's there? Because I'll admit I'm not patient in that respect. And how better can we leverage using that predictive piece to go ahead and tie that both to the contracting piece and to the supply chain, because it'll tell you something that needs to be replaced. But if that wasn't part of that calculator that sent a requirement to the agency and it was programmed and it was done, the administrative lead time and the production lead time may make it irrelevant because the part's not going to be available.
Thanks for the edification, sir. Next question is, how are the sustainment centers adapting to or preparing for the ACE concept that their customers are executing?
I could take a stab at that.
I'll jump in after.
Okay.
You wade in.
Well, I think what we've seen this week, and I think some of the challenges that we have to figure out based on the strategy that General Barry covered is, how do we get the stuff that we need to the right places, right? And all of that starts in the Sustainment Center. So, in General Miller's command over in Air Force Sustainment Center are the two supply chain wings, and everything that supports our Air Force starts right there. So a lot of work on how do we get the things that we need there, how to, to General Sanford's point, how do we predict what we're going to need. So that's some of the work I think we need to embark on when you think about ACE. So.
Yeah, and I'll just add, when we talk about ACE, there's the supply chains, and the supply chain wing and the complexes work hand in hand together, and they can literally say, we've got a certain amount of funding, we're going to push some things, but we're going to turn down the dial, say, on this production, on this LRU, because it has no effect on the aircraft that we have forward. But we're going to turn up the dial on a couple of other lines that we know we need to push those components or those assets forward. And I say push because if we have those right, that data analytics right, we'll know ahead of time what we need to be pushing forward to support that ACE concept. And so it's not aircraft, it's not production line, but it is the piece parts and the components that go forward that will help us in a surge scenario, whether that's a contingency or whether that's just some exercise or something we need to do, that we can think forward and work with the supply chain and have that response in the depot lines for commodities.
Yes, ma'am. Thank you both. So to expand on that just a bit, with demand planning being key in procurement, what efforts are being made to improve and expand data analytics on demand?
Could you repeat that?
I can. With demand planning being key in procurement, what efforts are being made to improve and expand on data analytics on demand?
So I can jump in. There are a lot of many different efforts going on. One of the things, and Blade somewhat fits into this, but we have IT systems across the board, specifically log IT systems. The figure came up before, it's 250 or 256, whatever that number is. And we're doing two things to help us really get more accurate demand planning. One is collapsing some of these old legacy systems that are just too expensive and too archaic to keep up. The other thing that we're doing is modernizing some of the ones that we intend to keep so that we can more accurately capture the data. The term dirty data and inaccurate data has come up several times. Part of that is the systems that we have because it allows the user to enter bad data. And so the log IT modernization efforts that are going on are really getting after being able to capture good data and then have that data mineable. So a tool like Blade can go in and get good data, turn it into analytics that turns around to better inform the requirements. It's a theme that we've talked about. Better requirements for DLA, better requirements for the depots to be able to posture for.
If it's okay, add too, Dare, I'd like to add too. So part of that question too, it talks about the loggy piece too, but there's an outside piece too that I think we have to make sure we take in consideration for predictive side, and that's whatever the flying hour piece is going to be. And so I'll give you an example. So we with the support of AVSOC, we entered into a pilot program that we're working with some of our analysts down at Richmond that's going to analyze the flying hour profile that'll be provided, and we asked AVSOC because they do fleet management for the MCs and the CVs, and so we're going to look at those and then focus on what that flying profile is. We've built a little model that we can put that in there, and it'll actually spit out to the stock number based on that flying profile, what could be needed. And I know, at least on our side, we're very excited about it, depending on what it provides, because then that gives us the key components that we think are needed to meet that mission set, and then we can then have a good data-informed discussion with industry to get them to focus on what we need to, and then we can actually have an informed discussion with OSD from a funding standpoint where we need investment funds. There's a mechanism for us to request those, at least on the DLA side, and so it's been supportive in the past, but what I would argue is we've got all the low-hanging fruit, and now we need to include that flying hour piece so that we can be a little more predictive. I hope that made sense.
Yes, sir. Thank you for those responses. Shifting slightly to a different lane, I know that your organizations were heavily impacted during, and maybe even still, during the COVID pandemic. Could you speak maybe about your organizational impacts or your mission impacts, whatever you'd like to share? We'd appreciate that perspective.
We have a real COVID expert on the panel.
Yes, we do.
That's true.
No, but I'll offer if it's okay, I'll offer from a DLA perspective. So we went into a max telework situation, and we have not come out of a max telework situation despite the HPCon changes. Now, where it's changed obviously is at the ALCs. We adhere to what the customer wants us to do. So if we need to be on site, we're going to be on site, and obviously in the touch portions, we're going to be there. So that part never changed. However, one of the lessons learned that we gained was from a training standpoint. So we have people being distributed, and even though you had supervisors checking on employees and they would get together virtually once or twice a week, there's still just some on-hand training, especially in the procurement and contracting area, that we saw fall to the wayside, especially with some of the newer employees that were inducted, because we've been doing this for 2 years. So it's not like we had a stagnant hiring piece. So we had new employees come in, and so that created some challenges that we're still working through, and we really only recently uncovered. And so we're seeing that in some of the administrative lead time, because as we look at our metrics, we're like, hey, why is it taking longer to do this? And so we're finding that was attributed to training, and we think a lot of that was due to COVID and people being out of the office. And then there's a cultural piece. I know me and my leadership are working very hard on, once you reconstitute, and now we use the term reentry, but reenter the force. After being away for like 2 years, there's going to be some cultural challenges in mission building and team building that we're going to have to do going forward that we're preparing for. So thank you.
So can I ask, I'm going to ask the panel member a question. It's probably not right in the ROE, but one of the things that we've said, like in a telework environment, sometimes it stifles that kind of innovative spirit that happens while you're in the workplace and there are 3 or 4 people together working on the same problem. And when you're in a telework environment, you kind of lose that. And I was wondering, Doc, I was going to pitch that over to you for just a second to see if you noticed that, because so much of what you all are doing is innovative.
Yeah, it's been terrible. So, what I deal with, right. It's, so, we do experimental work. We basically do metal forming, is what my team does. And, part of it is we do these innovative techniques, and the innovations happen by being in the lab together. And, so we've got to support those facilities, bring people together. And so we've kind of kept the pilot light on, and we've had a lot of Zoom meetings, and, got caught up on writing some papers and paperwork. And so we've been busy, but no, it's been tough. And, just, kind of more broadly, all these facilities, for kind of, the base of what you all do for manufacturing, are in decay and under challenge from lots of places. And I think COVID kind of pointed out some of this. But there's a saying backstage. There's this recent supply chain report. All the cabinet secretaries recently did a supply chain report, and DoD did one. And for physical things, 3 of them were fairly unsurprising. Hypersonics was one of them. The chip shortage in microelectronics was one. The batteries and electrical storage, but the surprising one was forgings and castings. And this is one of the places we're trying to do new work to try to come up with new, more agile things. We were largely shut down for about a year in what we do, and that's not. And there's a lot of challenges in that area. So as an academic, I'm kind of privileged. I get to see what students are doing. I get to deal with community colleges in part, and high schools even. And one of the things you're talking about too is we should talk later. Going a little off script here, off the rabbit hole, but we also have been working a lot with high school teachers with ASM Materials Education Foundation. We do metals, ceramics, composites, and we teach high school teachers how to bring these topics into high schools, and we've been very successful at getting material science taught in the high schools. So this is something that maybe we could talk more about, but we do need to put more people into those in demand, but maybe not always sexy careers. And that's one of the big problems that we have right now. I think we've got to get people in serving these very real needs. But yeah, so anyway, to start there, COVID's been tough, and I used a couple other things out of that too. But yeah.
If I can, Dara, I think the other piece of that question too is, so what was the industry impact? So different perspective. I mean, from an Air Force, at least from the pieces we managed, we didn't necessarily see that kind of impact. But from a joint force standpoint, yes, we struggled on a couple of weapon systems that primarily were supported by overseas suppliers. So as Europe in particular, where we actually get quite a few materials, they went into lockdowns earlier than we did. There was a lean couple of months while we tried to get material out of those countries, and it created some impacts. Not so much on the Air Force, but we did see it in other services.
So I think for the ALCs, I think it's probably obvious that we cannot do our mission from home. So for us, the challenge was, how do you work through this? How do we keep people at work through this? So first year, 2020, I think we lost over 600,000 man hours because of COVID, and that's the contact tracing and people going out. But as a whole, we never really stopped working. So that comes with its own challenges, because the same problems that everyone else had across our country, right? Kids not being able to go to school, how do we care for that? And then just the leadership challenge of, everyone is critical, everyone needs to show up. We can't fix airplanes from home. So I will say the positive in it, it forced us to look at some of the things that we've done traditionally, where we got, I would say, comfortable at the depot in terms of how we train, and people that are hyper focused on one thing. When that person gets COVID, who's going to do that now? So I can speak to Robbins. We're in the middle of kind of transforming how we train so that we're more multi-capable right across the depot. So COVID brought that to us. It was kind of a rally point for us to get smarter and work more efficiently. But it's been challenging, and definitely a leadership challenge in terms of the haves and have-nots. Not everyone on Robbins comes to work. A lot of people can telework there, so there's that dynamic. But I think for the most part, our people are proud of what they do and understand that they have to be there, and we've worked through it.
Thank you all for your responses. General Hammerstedt, we actually got a question a little bit earlier that I think might tie in nicely to your last comments. Are there any current efforts to increase automation in the organic manufacturing realm, perhaps as a result of some of the lessons learned during COVID?
Absolutely. So really excited to, in fact, I just learned backstage that my robotics expert is working with Dr. Glenn on things, which is great because he's a go-getter. So robotics is one area that at Robbins, for example, we've really embraced. We have right now 33 different processes that we have inserted robotics into our sustainment efforts. So a lot of that has to do with not just, as you said, like COVID and other capabilities, but also taking the human out of hazardous processes. So think about, depaint and, where we put people in respirators. So if we can remove them from doing that, that's a win. So we have a plan, a roadmap, if you will, to incorporate robotics into about 65 different processes in the next 2 years. So that's something that we're doing to add more automation, and we're seeing a lot of value with that. We're also doing a lot on the I would say alternative manufacturing side as well, which is also gonna kind of add to our capability from a automation and science and technology benefit.
Thanks, ma'am. Dr. Daehn, sir, we have a question for you. What would you need from the Air Force to help develop your tech, and will it be capable for point-of-need manufacturing?
Okay, good. It kind of comes up all with this. So robots are awesome. The other piece of robots is they tend to be more reproducible. You can use machine learning now, and one of the projects we're working on is trying to give robots the skill of an artisan, again, to be like a robotic blacksmith. And you can imagine that robot can do, one system might be able to do welding and metal forming and deformation processing. All of these things could be done, and the system can learn from itself. And these are things that you used to maybe get Fred to be able to do back in some shop somewhere, but Fred can have good or bad days, whereas a robot can replicate that all the same time. And if you do the machine learning right, you can do transfer learning and basically get those key ideas, then bring them to another shop in another part of the country. And I think that's really the way, largely the way forward that we have to do, is have this, what we call hybrid autonomous manufacturing, is something we're moving towards, where these systems can do multiple techniques, not just a system that does one thing, and then make it eventually autonomous. Because I think we do have a crisis in terms of the capabilities, the machine capabilities always being available, as well as the human capabilities always being available. And I think you'd be really careful about leaning things out too much. I think the automotive industry learned this when we went through COVID and all of this as well. I've been through multiple automobile factories. They always did this thing called just-in-time delivery, and all the parts would come and they'd be put together into a car would come out. And now when you have these supply chain challenges, you can have cars on order for a long time. So you have to be very careful about, I think, balancing robustness versus efficiency. And I think if you try to plan everything too carefully and say this has been the pattern, who would have expected COVID, right? Who's going to expect? Who knows where we're going with all these challenges? And I think it's the job of our friends here at the Air Force to be ready for whatever scenario might present itself. And you can imagine a lot of challenges, particularly where you can imagine supply lines cut to China, for example, where all kinds of primary materials and widgets come from. If that's cut, we've got to figure out how to make that ourselves. We don't often have the machines, the skills, and all of that. So I think this is a primary crisis that we really should be thinking at high levels about.
If I could ask a follow-up question, sir, based on your answer, I think you mentioned the balance between the need for robustness and effectiveness. What are some of the things you consider in finding that balance?
Yeah, robustness and efficiency. So again, the automobile industry, it's all been about efficiency. Can I save a dime here and all of that? And then when conditions change, you don't have chips in store, you don't have ways of getting that. So that's I think what you really have to be worried about, is don't lean things out too much. And you look at all kinds of systems, and efficiency and robustness don't often go together. If you have just the right number of people to do the job, when the conditions change, you're understaffed, and we see this all the time. So I think in lots of ways, in things like primary manufacturing technologies, we're very much leaned out as a country right now. We're short on people, we're short on skills and equipment, and if conditions change, going back, the reason we won World War II is we were able to manufacture ourselves out of it. We had the best arsenal for manufacturing in the world, and right now that advantage is with some adversary countries right now, and that's I think something we should be concerned about at a high level, and we've crept into this very slowly, and the ways out are will also, I think, take some time, and hopefully we have that time to do that.
Thank you, sir. General Sanford, another question for you, sir. Based on your work in the White House, can you elaborate a bit or share your perspective on the capacity in the Defense Industrial Base for surge operations, surge requirements?
So from a COVID standpoint, from a medical standpoint?
Either or. I'll throw that out there.
Yeah, so from a COVID standpoint, there was no surge capacity because there was no industry. So 85% of the material that was needed to support our medical facilities, especially in the PPE market, was made overseas, and primarily 4 countries. And one of those is not geopolitically aligned with us. And so it became very difficult. So it took us, as a nation, 4 months, 5 months before, 4 months, before we could start, based on investment, upfront investment, before material could start being turned out to, that was American-made, if you will, and be able to support our doctors, nurses, our medical technicians. So that was very eye-opening. We just had a talk at a session before. COVID is a great case study for logisticians because you went into a global fight, if you will, or a national fight, because the AOR was the United States and its territories and tribal nations. And even though there was a vaccine development on one side, in parallel that we're working, on the other side, there's getting the immediate medical devices and equipment that's needed to support your medical technicians, which I viewed as maintainers. And so how do I supply them? And so vaccine took time. You had an immediate need over here that you needed to work, and then you found out you had no industrial base, so there was nothing to surge, and the Defense Production Act wasn't going to help you when you're going from zero. Yep. So it took time. And so we ended up managing scarcity, which we don't want to do in a war. We may have to in some items, but we have to minimize that as logisticians. And so that is what we worked through over 15 months.
Thank you, sir. How is the relationship between DLA and the ALCs growing in regards to utilizing the capabilities of organic manufacturing to meet customer requirements and timelines?
I have to defer to my customers because my success is their success.
So how is the what? Can you repeat that again? I'm sorry.
Yes, ma'am. How is the relationship between DLA and the ALCs growing in regards to utilizing the capabilities of organic manufacturing to meet customer requirements and timelines?
Organic manufacturing.
Yeah, I think we had a really good success story lately up at Ogden with Brigadier General Gibbs's folks. I think we could do better. The position that, or the piece that we uncovered with when we were doing some A10 stock numbers with Ogden was that the process, the way it's lined out, and this is like agreed upon between DLA and the Air Force, it was like 9 months, and that's unacceptable. And so what we found with these 15 stock numbers is that we could rush it through the system. Now it took geo involvement, which we don't want that to happen all the time. But we got it done within, I think, 30 days, 35 days from start to finish. And so the AOC could start manufacturing. So what we did is, thanks to the great leadership by Steve Gray, we partnered with him and his team to do a CPI event across the ALCs and through DLA, because DLA has a big portion of that. There's the manufacturing piece, but to get to that manufacturing piece, there's a big portion. And so to include funding. And so that CPI event, I think, will hopefully shrink that, and we don't ever talk about 9 months again. And it's always based on a 30-day timeline. So I think that's where we need to go. I'd like to see more organic manufacturing. I think there's a taboo out there that people think, oh, no, you put it on contract, I can't do any more organic manufacturing. And that's not the case. And that's something I've had a discussion with via email with the AOC commanders, is that if the lead time's not going to meet your requirement, and you can do that organically, we are all about doing both. You can have the long-term contract to satisfy the need, but we can do organic manufacturing in the short term, and I think we need to leverage that more.
Yeah, we actually do a tremendous amount of organic manufacturing at Robbins through as DLA as our customer, given the weapon systems that we sustain there and the age of those weapon systems. I think the C5 and others. So, and I think that's It's been great. Again, given the timelines, and the hard part is, we go through the process of establishing the demand and just trying to figure out what is it that we're going to need, because there's so many. So we'll establish a local stock number, and then we have to decide which ones do we want to actually reproduce, which ones do we think we're going to need, which gets back to predictive, what's going to fail of the thousands of parts that we need as that aircraft goes through PDM or in the field. But we have a lot of success, again, at Robbins, given the weapon systems that we sustain there.
Yeah, I'll just add one piece to that. When we talk about surge capacity of the entire defense and base, both the organic industrial base and then the commercial industrial base, the surge capacity, the immediate surge capacity is organic manufacturing. And so it's as General Sanford said, I mean, in the short term, if the complexes have to be the ones to manufacture and get things going while commercial base spools up, that's the plan, and that is the capacity we have to keep, and we have to exercise it by doing things like what we're doing with the A-10 and C-5. So.
Yes, ma'am.
Excellent. Thanks so much for those responses. One question is, how is AFMC battling the long airworthiness approval that delays the use of products created with new tech? And the example they offered was metal printing.
I'll let General von Hoffman clean up what I'm going to say about this, but it's really challenging. The seat that I sit in, it's challenging because, again, this is at scale. I mean, there are thousands of parts, and I see Steve Gray out there. I wish he was up on the stage with us, but so it's a lot of bandwidth for our program offices, right? Because ultimately, everything that we do on the weapon system is approved by our program offices. So it has to be approved by engineering and sourced, and so we have been working hard to try to manage that bandwidth and try to, again, be predictive. What are the things that I think are good targets of opportunities for cold spray and HVOF and other techniques that are out there, so that we can target certain parts or families of parts so that we can get after that. Because really on the legacy platforms, that's going to be a game changer for us. We just need, we can't do it alone. We need the support from the program offices to be able to do that. And I understand completely the challenges on their side, so it's not meant to be a critique of them as a partner. It's a lot of work and a lot of bandwidth. So we have to come to the table with good proposals on what we think the right stuff is, at least at the beginning.
Yeah, I don't have much cleanup to do
Okay.
on that, except to say I can't really see from the lights, but we do have a phone a friend somewhere in the audience, and that's Jeff King. I think he's there. We were just talking about yesterday. There's this common theme that these parts that we produce are good to go. It's just the engineers that are saying no, and that is less than true. Mm-hmm. So. When we get everybody in the room together, and that is something that he has literally worked on. He goes, okay, I know that there's 15 ways to say no, but let's get all those 15 no's in the same room and figure out where's the yes.
Do it faster.
And so we are working through that from the complex engineers, the AFMC lead engineers, and then of course the program engineers in concert with the maintainers that are working through this. So the theme is not that we are not going to be printing air parts that are airworthy. We are. It is really refining that process and making that a much shorter timeline than it is right now.
Okay. I think we have 5 minutes left. Is that what you see on your clock, Colonel Fekete?
We do. We have about 5 minutes, and I do have one follow-up for Dr. Daehn, going back to the opportunity to partner with academia. We do this a lot on what we call the wholesale side, I think, of the business, and through Air Force Research Lab and the Rapid Sustainment Office and whatnot. What opportunities do you see, or how can we bridge the gap to do it more on the retail side, on the people that wear the uniform every day at the base level?
I think yes. Thank you for that. Yeah, I think it's a good issue. I mean, we in the academics, it's wonderful being part of this culture, seeing you deal with sort of the same things we do. We have all these silos. We in academics have the same things. We have two places that are a little too deep in their own culture. We in kind of engineering school, it's teaching PhDs to kind of go deeper and deeper into topics. And we often need the kind of the demand signal of what is really needed from communities like this, so I'm really happy to be part of this. So we at Ohio State have a fairly large lab with additive manufacturing, deformation, casting, welding, and so forth. We would love to be part of helping figure out if there are other ways of making parts, how to take things that are additively manufactured. Are there ways we can improve the process, make them airworthy, and so forth? And there are a lot of people working on this, but very often it's done in the context of a PhD thesis, which is you go deeper and deeper and deeper with one small issue, rather than really trying to redesign the process with all the tools that are out there. And I think that's some of the retail opportunities that I think we might have, is to try to find organic problems where we can work together. And I think there's a lot of opportunities where the academic institutions writ large, not just Ohio State, can be a bigger part of the solution. And we'd love to be part of understanding at the think tanks and so forth, and trying to guide long-term and short-term policy to serve your needs.
I appreciate that, sir, and I appreciate the working relationship we've had now
it's been great.
for the past couple of years, and being able to bring some of the base level issues to you, and then introduce you to the larger crowd. I think that's...
And we're learning what the real authentic problems are too. We have our ideas of what the problems are, but we don't know until we have these deep discussions. That's part of it. And
it's been excellent for me. So with a little over 3 minutes left, if there are no more questions from the audience, I will thank the panel members and thank you all for being here today. I appreciate it, and I'm not seeing any other questions. Okay, we're good. There's one over here, one hand raised.
Oh, no.
Colonel G. M. Kuzma, I have a question on the recruiting of talent. You're going into the schools and you're getting them homegrown. Are there any discussions as far as sort of flipping the script, going for talent that might be in Seattle that could work in Middle Georgia?
my only big thing is hit them early. Try to get into the middle schools. Try to get people understanding that making things, these problems with software, are real career opportunities. A lot of my colleagues, we focus on getting people to be engineers. What I see the real crisis is at this kind of mid-skill level. It's actually very high skills, but not necessarily high degrees. And I need these people in my lab too. I need lab technicians and the like that can actually do things. And there's some great careers that I know are really underserved. And but it's you gotta get authentic hands-on problems into fairly young ages, middle schools and up.
Absolutely. I would say that I bet you we are targeting Seattle. So I think, we at Robbins, we kind of have our region. I mean, we could hire every graduating, computer scientist or electrical engineer from every university in Georgia and still not have enough, right? So we are expanding. We're into Florida. We've found that if you start to go too far, people don't stay. So we do have an eye on retention. We do best when we can recruit from the region. People like to come home. So we don't necessarily retain people that come too far, but I would guess that Ogden, that would be attractive to someone who's in perhaps Washington State. So I think that together the three ALCs, we're probably spanning a large portion of the country, but it's just that we're all competing for that same resource. And when it comes to, as I mentioned earlier, money, telework, flexibility, sometimes we just can't compete, and that's the challenge. Yeah. Mm.
Excellent. So with that, I would like to thank the panel members again, and thank LOA for the opportunity to moderate, and thank you, Dr. Daehn, as well. And thank you all for attending. Have a good evening.